Hello students, today we will learn about quadratic equations, particularly the solution of quadratic equations using a quadratic formula. So for this, I am over here on a Desmos calculator where we can draw also the quadratic equations in the form of parabola. As you know that the shape of quadratic equation is actually a parabola. So what the parabola is, let's first have a look, and by considering a simple quadratic equation where we do have that y is equal to, yes, one second, that y is equal to x square negative x negative 6. So this is our quadratic equation, and its graph is a parabola that you can see in this diagram. So first, let me give you a very quick introduction of this parabola. So if you look carefully that what is happening, that this shape is a U shape, and this U shape, we can call it that it is a positive parabola or it is a negative parabola. What is the meaning of the positive and the negative parabola? That if we have this equation, y is equal to positive x square negative x negative 6, then our parabola, which is defined by the quadratic term means x square term, and that term is positive. So then our parabola, it is actually in U shape, and this is what we call it, a parabola is positive. But if, for example, we have the same equation, but this time we have a negative equation here, meaning that the x square term is negative, then you can see that our parabola is negative. Okay, so this is the first thing that we can actually need to remember, that the difference between a positive parabola and a negative parabola, and it is all from the quadratic term. Quadratic term means x square term that could be either positive or negative. And we are taking here the positive square term, meaning the positive parabola. And then in this parabola, there are four more important points. Number one, over here, you can see that the point where the parabola is crossing the x-axis. And here you can see that actually there are 2 points, the point number 1 and the point number 2. And these two x values where the parabola is crossing the x-axis are known as roots of the parabola. In other words, you can say that when y is equal to 0 and the values of x are the roots. So you can also see with this shape that if I move it up, then these two values of the roots, they will be coming closer to each other, and ultimately we will have only one root when it is just touching the x-axis. If we will move it more, then it will go above the x-axis, then in that case there will be no roots of the parabola. But this is not exactly true, because we still can have the roots, but that roots will be complex. So we must say that in that case, there are no real roots. But when it is touching only just the x-axis, then there are two equal roots, because both of these roots, they are coming closer to each other and they combine with each other. So both are the same roots, or you can say there is only one root. This is a very simple introduction of roots. We will actually learn more when we will be solving this equation, particularly using the quadratic formula. And the second point, or you can say the third point, it is the point where the parabola is crossing the y-axis, that what we call it, that it is y-intercept. This is a y-intercept. And this y-intercept, you can also see from your equation that it is a constant value, -6 here, which is over here. And this is very easy to find when you will just look at the equation. The constant term is our y-intercept. And as you also know that in a very general form of the quadratic formula, we have y is equal to ax square plus bx plus c. And here, this c is actually the y-intercept. You see from this graph that at this point, our x value is 0. So now from this equation, you can also see that when x is equal to 0, y is equal to c. This is the y-intercept. And this was our third important point. The fourth point, this point is the turning point. And this point is always exactly at the center between these two values of roots of this parabola. So that what we call it, this point from before, that we call it the turning point. That is a turning point. Now, we had a very simple introduction of our parabola. Once again, the parabola can be a U-shaped, which we can term it as a positive parabola, which depends on x squared term in our quadratic equation. If x term is negative, in other words, you can say that from this general equation, that when this a is positive greater than 0, that means our parabola is positive. But if our this a value is smaller than 0, meaning that it is negative, then we will have our negative parabola, and parabola will flip upside down and you will have opposite view. And in a parabola, there are 4 important points. So these 2 points where it is crossing the x-axis, meaning y value is 0, and that values of x, we call them roots. Then the third point is a y-intercept where x is equal to 0. The fourth point is the turning point where the parabola turns its trend. And that value is exactly in between the values of roots. Now let's move ahead and try to solve this parabola using our this quadratic equation using the quadratic formula. So for this, let's have a small green board here. Now we look at the quadratic formula. What quadratic formula is? Quadratic formula is the following, that the value of x is equal to -b plus minus square root of b square minus 4ac divided by 2a. Now, here you see that this formula we use to find the values of roots, to find the values of roots. And roots means the value of y is equal to 0. Then it means the equation that we have considered here, it must be like x square minus x minus 6 is equal to 0. So this equation will be satisfied if the values of x are according to this formula. And then here you can see the values of a, B, and C are the following, that A is equal to the coefficient of x squared term, which is A, then the value of the B is coefficient of the value of x, then the coefficient, so C is just the constant value, which is -6 here. Now we put these values in this formula and find the values of the roots. So x is equal to -1, so it will turn into positive. So we have a plus minus square root of b square, which is 1, then -4 times a, 4 times 1 is 4, then C is -6, negative plus 6 times 4 is 24. Now this whole is divided by 2a, a is 1, so by 1. Now we can solve it. So this one is +1, then plus minus 24 plus 1 is 25, 25 square is 5, 5 divided by 2, that are the values of x. Now you can see that there are two values of x. The value number 1 of x is that when we consider that this 5 is positive number, so +1 plus +5 is +6, divided by 2, answer is +3, which is our point number 2 over here. And then the x1 is equal to when 5 is negative. So +1, -5, answer is -4, divided by 2, answer is -2, which is over here. This is a point number 1 in our diagram. So these are two roots of parabola. So roots are conditioned. Here you can see when y is equal to 0. So it means that this equation can be satisfied with these two values of x, and these are the only two solutions of this equation when y is equal to 0. So this is a very simple method of finding the roots. In an actually other way, today's calculators, you will have this quadratic formula, where you can actually just put the values of a, b, c, and you get the values of the roots. But why actually I still want that you people must understand this quadratic formula in more details. The reason is the following. Let's go to understand this parabola and in terms of the quadratic formula. So now I remove all the things and keep only the quadratic formula here. Then in this quadratic formula, you can see we have one term in the numerator which has two signs, positive and negative. So what this positive and negative signs tells us, that actually x has two values. X has two values. So this means if we will have b square minus 4ac greater than 0, meaning it is a positive value. If it is a positive value, so then it means we can solve the square root. So ultimately we will have two values of x. So we will have two values of x, meaning there will be two roots of x. So two values of root means the parabola is crossing the x-axis at two different values of x. This b square minus 4ac, this is actually, you can say, the expression which tells us the nature of our roots. So we call it discriminant. This is discriminant. So discriminant tells us the nature of roots. So now when this discriminant is a positive number, so we will have two real roots. So we will have two distinct roots. Now if this term b square minus 4ac, meaning discriminant, is smaller than 0, meaning it is a negative number. So if we have a negative number under the square root, then we will not have a real solution. So there is no real solution. So this means no real roots. So this kind of parabola will have no real roots. The third condition is if we have b square minus 4ac is equal to 0. If we have this condition, then now you can see then in our this quadratic formula, the second term of numerator, which has two different signs, and these two different signs are giving us two different values of x, is not present anymore. So in this case, we will have the value of the x is equal to negative b over 2a. And so this will be the only one root, or as in the beginning, I told you that when we move our parabola up and the parabola will be touching only at one single point with the x-axis, meaning that these two roots actually moved toward each other, and then at the end they connected with each other. So that is why we can also say that there are two equal roots, two equal roots, meaning the both roots are equal to each other. In simple words, you can say only one root of the parabola, only one root of the parabola. And what that root is? X is equal to negative b over 2a, where that root would lie. So this root will lie at the turning point over here. So this is the turning point, because if we move this parabola up, then this point will be touching our x-axis and it will give us one single value of the root. Now let's test our this single root value of our this example. Y is equal to x square minus x minus 6. That what will be the answer? So now, so in this case, x, the value turning point is equal to negative b. So b value is 1 over here. It is a negative 1 actually. So it will be negative 1 is a positive 1. Divide by 2a, which is 2, and answer is 0.5. So this 0.5 is a turning point, is a turning point. If this is a turning point, you can also see that if, for example, we draw an equation that y is equal to half, then we will have a line, and that line will be parallel to the y-axis, because this is infinite, you can say the gradient, and then we will have just parallel to the y-axis. So this equation or this line have an equation of what? That x is equal to 0.5, which is our turning point, and this equation giving us a line, and that line is dividing this parabola in two equal parts. So if it is dividing in two equal parts, so you can also say that this line is actually also the line of symmetry or axis of symmetry of this parabola, So now this is actually, you can say, the magic of quadratic formula. We must learn this quadratic formula in this way, that how it can explain us the nature of the roots and also the turning point and then the axis of symmetry. Now, this x value, which is 0.5 in our example, or in general, x is equal to negative b over 2a, this is x coordinate. This is x coordinate of the turning point. If you will put this value back here in this equation, you will find the value of the y, which will be the y coordinate of the parabola. So this is a short introduction of quadratic equations, parabola, and quadratic formula. Now, in the next lesson, I will discuss the next two methods of solving quadratic equations, that are factorization and completion of the square, or completing the square. And we will also discuss that what that solutions explain us about the parabola, about the quadratic equations. Thank you very much for watching, and never forget to subscribe. Thank you.